Alright, so I'm looking at this Amiga 1200 motherboard here, and the revision is 1D. Now again, this is not my motherboard. I was asked by a guy from an Amiga forum to have a look at this, so I will do that. Now this motherboard has a problem with the video output, or actually two problems with the video output, which I'm not sure yet whether they are related or not, but I'm gonna have a look at that and hopefully I will find out. Now the first problem is that I'm not getting any picture at all from the RGB output here, and that could pretty much be considered being a problem, I guess. And then from the composite output I am getting a picture. However, that picture is kind of distorted, so we can see that here, that it looks kind of strange. It looks like I'm getting all colors on screen, R, G and B, but there's something else going on here. It's kind of distorted and just looks really strange. And now if I go into a program like Pro Tracker, for example, and I move the slide bars for each color respectively, R, G and B, and then I can see that the colors are changing smoothly, and it looks like all this we have the whole spectrum there. For example, the red color is changing from the least amount of red to the maximum amount of red smoothly, and there are no problems there. So it seems like we have the full intensity of red, green and blue, so I don't think there is really any problem with the red, green and blue colors as far as the digital part goes, before the digital to analog conversion takes place. But anyway, I will take a look at this and see if there's anything I can do about it. I think I will start with the RGB output and see if I can get any life in that output again. And then I will move on to this kind of strange distortion thing I'm getting on screen. Okay, so why am I getting a picture from the composite video output but not from the RGB output? Let's see here. There are 5 signals needed in order to produce an RGB picture on the TV. First we have the RGB signals, red, green and blue, and then there's the composite sync signal, which contains a lot of sync pulses. There's no video information in there. And then we have the switching voltage in order to switch the TV into RGB mode. Now I don't suspect the 3 RGB signals to have anything to do with the fact that I'm not getting any picture from this video connector, because if you take a look at the schematic here, we can see that we got our red, green and blue analog video signals coming out from the video DAC right here, and these 3 signals are AC coupled into the video encoder, and the video encoder takes these 3 signals and encodes them into a composite video signal, and we got that output right here at pin 20 of the video encoder. So that composite video signal is going through an AC coupling cap here. We got some series resistance there, and it's going to this RCA jack right at the back of the Amiga, providing us with our composite video output. So I don't think that there's anything wrong with the RGB signals, because we did get a picture from the composite video output, so that means that there must be something coming into the inputs of the video encoder, or the video encoder wouldn't have anything to encode and there would be no picture on the composite video output. So I think that the reason I'm not getting any picture on the 23-pin video connector is that there is some problem with the composite sync signal, or a problem with the voltage, switching voltage. Yeah, there could be a problem with these three resistors also, but well, in that case all 3 of them would be open or something. That's not very likely. I mean, if one of them was open, then at least I would see the other 2 colors, but all of them are open. Not very likely. So, but yeah, I guess I can measure from here, from these points. I think it's pin 3, 4 and 5 on the 23-pin connector, and here right at the video DAC, I will measure that and see if I'm reading around 25 ohms, just for the sake of it. So the 3 analog RGB signals can be found at pin 3, 4 and 5 of this D-sub connector. So I'm going to put one of my probes right here at pin 3 to start with, and then the analog outputs from the video DAC are in this area. So I'm going to start checking the pins here. and I should get a reading of around 25, and I got it there. And then the next one, I should find a pin here close by. Yeah, there we got it, 25. And the last color here, I guess, yeah, there we got it, 25 ohms. So everything is in order. It's not like I think there's anything wrong with it, but I'm gonna check the composite sync signal right here at the D-sub connector just to make sure. So we got a composite sync here right at pin 10, and we got a horizontal sync at pin 11, and the vertical sync at pin 12. And I got my oscilloscope probes connected to pin 12 and 10. So I am triggering on the vertical sync, and I'm checking the composite sync with the other probe. So let's take a look at the scope. So here we got our vertical sync signal going, and I'm triggering on this signal now. So you can see we got our sync pulses here. And if I change the time base, we can see that we have one sync pulse here and one there. And now the scope is a little bit out of cal, so I will have to fix that later. But anyway, we've got 10 divisions between here and here, and the scope is set to 2 milliseconds per division. So we got 20 milliseconds between these 2 points, and if we do the math on that, we will find out that that equals 50 Hertz. So that's pretty much as expected. So now let's switch to the composite sync signal. So let's see here. Well, this looks pretty much like a normal composite sync signal to me. So nothing is wrong with the composite sync signal, it seems. Okay, let's see, analog red, green and blue, check, they are all reaching the connector, and the composite and horizontal and vertical sync signals, check, they are all working fine, and that leaves us with the switching voltage, and that is usually taken from pin 23, the 5 volts rail. So if we take a look at that, we can see here that here we got a 23 pin connector right here, and pin 23 is here. And then that is connected to a VCC through this ferrite bead here, but yeah, it's maybe an EMI filter or something, but it's zero resistance basically. So no resistance between VCC and pin 23. So let's see if that's how things are actually connected on the motherboard. You know, it looks like someone has been going at it with a soldering iron quite a bit, because if you take a look here, we can see that there are 2 hole-through resistors in there. Kind of funny. And it also looks like someone has been soldering a bit on the SMD components as well. So maybe that has something to do with this problem. So I'm gonna measure those components and take a look at this. Okay, now VCC, or the 5 volts rail, can easily be found at the left pin of the power connector for the floppy disk drive. So I'm gonna put one of my probes there, and I'm gonna take my other probe and put it at pin 23 of the video connector. So let's see what we get here. 9.82 kilo ohms, so almost 10 kilo ohms. That's insane. We should get basically 0 ohms there, not 10 kilo ohms. I bet it's this resistor there, this hole through resistor, you know, that someone put in there. I'm gonna check that one. I bet it's that one. Yeah, 9.82 kilo ohms. It's that one, alright. Oh, what are people doing to their Amiga motherboard? Seriously. Someone must have been thinking like,
yeah, I know. Let's take a 10 kilo ohms resistor and put it between VCC and pin 23 or the video connector, because if I do that, then my Amiga motherboard will work so much better.
I thought I would explain what's going on here in case you're wondering. So inside Amiga, pin 23 or the video connector should be connected directly to VCC or the 5 volts rail. So there shouldn't be any resistance between VCC and pin 23 here. So we got our switching voltage coming out from pin 23, and that is going through a resistor in the cable, which is usually around 100 ohms. So that resistor is located in this hood here, or inside this, this shell case. So we got a 100 ohms resistor there, so the switching voltage is going through that resistor, and then it's going into the TV. And inside the TV there is a 75 ohms resistor connected to ground. So it's like a terminator resistor. And this 75 ohms resistor, together with this 100 ohms resistor, creates a voltage divider. So the switching voltage output is taken from here. So in order to simplify this, we can take a look at this. It's basically like this. This is the same circuit. So we got 5 volts here from inside Amiga. It's going through 100 ohms inside the cable, and here, and then it's going to the 75 ohms resistor inside the TV down to ground, and this is taken, the output is taken here inside the TV. So this part is inside the TV like this, and 100 ohms is pretty good value to put in the hood here, because we can do the calculations here kind of easily. If we have 75 ohms inside the TV divided by 75 plus 100, and we close that bracket, and we get 0.42, and then times 5 volts, and that will be 2.14 volts. So then we got 2.14 volts going out there, and that's really a good voltage, because the TV wants around between 2 and 3 volts is a good voltage for the switching voltage. Now let's calculate this again, but this time we can calculate it with the 9.82 kilo ohms resistor. So 9.82 kilo ohms equals 9,820 ohms, and then we have to take this 100 ohms into account that is in the cable. So then we got 9,920 ohms suddenly. So if we do the calculations again, then, well, 75 divided by 75 plus 9,920, close that, and then that equals 0.0075, and then times 5 volts, and then what we're getting out here is 0.0375. So 0.0375 volts, and that is not enough to switch the TV into RGB mode. This 2.14 volts, that's enough, and that's a good voltage, but 0.037, no, that's not enough to switch the TV into RGB mode. So it's not strange that I didn't get any picture from the RGB output. So this 9.82 kilo ohms resistor, that shouldn't be there. Instead, there should be an EMI filter in there, which basically means 0 ohms between VCC and pin 23 here. So that means that if I short this resistor out, then I will restore the 0 ohms between VCC and pin 23, which should bring the picture back. So let's try that. So if I short this resistor out with one of my probes here, let's see if I can do this here. Okay, and voila, there we got the picture back. And if I remove this probe, then the picture is gone, and I short the resistor out again, and there it is. So that problem is fixed. Now there is still some distortion going on screen, so I will still have to fix that, but well, anyway, we're making progress at least. So I got this small EMI filter in there. Now unfortunately I didn't have the right size. It should be a slightly bigger one. I guess the size should be the same as this one and this one, but I didn't have that size, so I had to put this small one in there. But at least it's SMD, and it looks much better than putting a hole through component in there. So it will have to do for now. I will order the right size later and put that in there, I guess, but just for now this will do. And I got my picture there, RGB picture. Alright, so now when I'm getting a picture again from the RGB output, it's time to take a look at the other problem, you know, this strange distortion thing going on screen. So to start with, I don't think there is anything wrong with these data bits coming into the video deck, because as I was moving the slide bars in ProTracker, I got a smooth and good response from each one of the three colors. So I don't think that this part has anything to do with this problem, and I don't think that this diode network has anything to do with it either, because a few diodes cannot affect the signals like that, I think. So I'm more interested in this circuitry here, which has to do with the reference voltages. Here we have voltage reference and reference white here, and VS adjust. I'm not really sure what that does. I could download the datasheet for this video deck and have a look at exactly what these different pins are doing. But to start with, I'm gonna take my working motherboard, because I have a working motherboard of the same revision. So I'm gonna take that and I'm gonna measure the voltages here, and I'm gonna compare that with the motherboard I'm working on and see if I can find any difference. Now, as it just turns out, I might not have to do any measuring at all. Can you see what I'm seeing? So to the left is the working motherboard, and to the right is the motherboard I'm working on. And what is different? Well, if we take a look here, this little component, where is that on the other motherboard? It's missing. So I will borrow that from the working motherboard, just temporarily, and put it onto the other motherboard and see what happens. Alright, so I got that little component into place there, and check it out. Looks a lot better, doesn't it? So, I guess that fixed the problem. Now, I did just borrow this component, so I will put it back onto my motherboard. But I will see if I can find a similar component that I can put in there. And then I will also have to take a look at this. I don't know what this resistor is doing there. I will have to take a look at that and remove it and put an SMD component in there and do some resoldering here. You know, this is kind of sloppy done, so I will redo that. But anyway, now I know what the problem is. And of course, if I now try to power up my own motherboard without first putting that component back in place, the picture will just show up like this again. Now, like I said, I just borrowed this component temporarily, so I will put it back onto my motherboard. But before I do that, I want to find out exactly what it is. And it pretty much looks like a capacitor to me. So I will measure it and see if there is any capacitance in there. And I have the meter set to capacitance check, so let's see here. Yeah, around 50 nanofarads. Now, I did have a look in my drawer just now and check out what I found. This thing. And this is rated at 47 nanofarads, but when I measure it, it's about the same. Yeah, this thing should do the trick, I think. One thing that is kind of interesting is that this 50 nanofarads capacitor is not represented in the schematics. Now, I did take a look at the motherboard, and this capacitor is connected to pin 18 of the video deck, and the other side of that capacitor is going to ground. So if we take a look at the schematic here again, we can see that we have pin 18 here, and if we imagine this being our 50 nanofarads capacitor, then this side of that capacitor should be connected to ground. But this is not that capacitor, and neither is this. So, you know, we don't have any 50 nanofarads capacitor in this circuit here. So, that capacitor is simply not in the schematic. Interesting. The capacitor I temporarily borrowed is back again on my motherboard, but here we're looking at the motherboard I'm currently working on, and we can see that I got the new capacitor in place there, and everything seems to work just fine. So now I just have some additional cleanup to do, like resoldering some components here, removing this resistor and putting a suitable SMD component in there. But after that, I'm basically gonna be done working on this motherboard. this resistor that was in there, it was the same as the other one. So this one is also showing around 9.82 kilo ohms. And then this one is the first one I took out. And it's measuring the same. Now, as you know, there was a 9.8 kilo ohms resistor in there. But guess what should be there? A 100 picofarads capacitor.
Yeah, I know. I would take that 100 picofarad capacitor out of there and put a 9.8 kilo ohms resistor in there instead, because if I do
wait,
that...
stop.
Huh?
I don't want to hear it, okay? Okay, so that's it. I'm done working on this motherboard. So just to summarize it, I desoldered a 9.8 kilo ohms resistor that was in there and put a farad bead in there instead. I resoldered these three resistors, this, and this, because they were kind of sloppy soldered into place there. I desoldered the 9.8 kilo ohms resistor that was in there and replaced it with a 100 picofarads cap. And I also put 50 or around 50 nanofarads cap in there. So yeah, and the board is working now again, and everything is back to normal. So I'm pretty much done working on this motherboard.
But I know. What if I desoldered the Alice chip and put a resistor
Hey
in there?
dude, can you go away? I'm not really interested in listening to your brilliant ideas, okay? So where was I? Oh yeah, right. I'm pretty much done working on this motherboard, so I guess that's it for this video. I hope you enjoyed watching it, and feel free to comment.
No,
and
wait,
rate.
I know. What if I remove one of the smoothing capacitors and put a resistor?
Just go! So feel free to comment, rate, and all that stuff, and I will see you in the next video. Thanks for watching.